Welcome back, everybody. So for this lesson, we're going to put into practice some of the trig stuff that we learned last unit with some real life problems. So hopefully you'll be able to correctly identify and use angles of elevation, depression, be able to understand answers in context. So what makes sense? What are we saying? What are we asking for? Things like that. Important vocab, angle of elevation, angle of depression. So we'll get started. So when you think about angles of elevation, depression, for angle of elevation, think about you looking straight out. Okay, so you have this, let me change colors here so maybe we can better. We have this line here that's like a horizontal line. If we have to look up, okay, if we have to look down, that's depression. Now, I know I haven't learned about parallel lines and transversals yet, but we're going to see later on that these can usually go in the same place, unless a question is specific. What I mean by that is if I'm here, let's say here, okay, and I'm looking across and I'm looking, the angle of elevation would go here. But because of parallel lines and transversals, that angle could also here. So the angle of depression from the top to the bottom is the same as the angle of elevation from the bottom to the top. So let's just look at some examples here. So we have, you get to see someone beautiful here. A power line is connecting the top of a building to around 260 meters away from the base or the bottom of the building. At what angle is the wire connected at the building if the wire is 340 meters long? So this is building here. Again, notice my abilities. Okay, we have a power line from the top to the bottom. It says it's 260 meters away from the base of the building. And the wire, which was this, is 340 meters long. We're looking for the angle. Now, because it's angle of depression, the angle, it's connected to the building. So if I were looking straight out here, what's this angle right here? Remember, that can also here. So the angle of elevation from the top of the building to the bottom of the wire is the same as the angle of elevation from the bottom to the top. So I sometimes like to draw my triangles, all of the pictures. So the first thing I'll do is I'm going to label my triangle. Here's my reference angle, what I'm looking for. My hypotenuse, opposite, adjacent. So the two things I care about are A and H. Now remember last unit, when we're looking for an angle, it's cosine because it's A and H, and because for the angle, we're going to do inverse cosine. So inverse cosine of 260 over 340. If I type that into my calculator, I should get 40 degrees. So when I do this, it's a word problem, okay? So I need a word answer, and it can be pretty simple. Angle is 40.1 degrees. Okay, so there's one example. We're going to come back to this one. So let's look at after flying at an altitude of 500 meters. So 500 meters, or altitude, sorry, means height. Okay, so we have a height of 500 meters. A helicopter starts to descend when its ground distance, so here's the ground, is in kilometers. What is the angle of depression? Now remember, technically that would go up here. But because of parallel lines, alternate interior, and I know you don't know that, but it can also go here. It's the same angle. So that's what we're looking for. Now I see a problem here. We have meters, we have kilometers. We got to convert them to the same thing. So I think the easiest thing here is going to convert 500 meters into kilometers. So 1,000 meters is 1 kilometer. So this is actually, if I do 500, I need to switch those because my meters need to cancel out. If you've taken unit analysis, you'll know that. I apologize for that. 1,000 meters is 1 kilometer. So 500 divided by 1,000 would be 0.5 kilometers. So 500 meters is also 0.5 kilometers. So now I have common units. So if I label my triangle, here's my reference angle, hypotenuse, opposite, adjacent. So the two things I care about are opposite and adjacent. So x is going to equal tan inverse of 0.5, because that's opposite, it's opposite over adjacent, 11. So x would equal, when I type that into my calculator, 2.6 degrees. Now when you think about that, you don't really want to descend at too much of an angle. So that kind of makes sense. So the angle of depression is 2 degrees. Okay? All right, let's do another one. Let's see. So we're going to do another one of these. So I'm going to leave that one here. We'll look at this one. Well, let's see. All right, let's do this one. Tara is trying to determine the angle at which to aim her sprinkler nozzle to the top of a 10-foot bush. Okay, so here's the nozzle. Bush is 10 feet. Assuming the water takes a straight path and the sprinkler on the ground is 4 feet free, what angle of inclination, another word for angle of elevation, she said it. These are not all going to be ones where we find an angle, so don't think that's true. So here's our reference angle, our hypotenuse, our opposite. So again, we care about opposite and adjacent. So it would equal tan inverse, opposite on top, adjacent on the bottom. So the tan inverse of 10 divided by 4 is 68 degrees. So that should be a capital T. Angle of elevation should be 68.2 degrees. So we're using all this we learned from trig, but now putting it into word forms. All right, so let's go back and look at this one. All right, so two boats. Okay, so I'm going to draw two boats here. Are observed by a parasailor. So the parasailor is up here, 75 meters at angles of depression of 12.5 and 7 degrees. Now, this can get a little tricky, but when you think about being up, the further your head moves downward, the bigger that angle becomes, the closer the object is. If you think about something looking directly below you, your head is almost at a 90-degree angle. So this bigger angle would actually be the 12.5. And smaller angle, the smaller angle would actually be the 7 degrees. So because we're doing angle of elevation, we need to think about this, not there. And I did that because that's a common mistake, but we need to think about here. Okay, so the bigger one is this 12.5, whereas the smaller angle is going to be the 7 degrees. Now remember, those can also go here and here. So I really have two triangles. What we're trying to figure out is how far apart are they. So I have one triangle where this is 7, this is 7.5, and I want to know this. So that's be like this whole distance with the 7 degrees. And then I have another triangle where this is 12.5. We'll call this Z, and this is still 75. So this right here is the Z. So you have kind of two problems in one. So if I label, let me go back to yellow here. If I label both of these, this is opposite, this is adjacent, this is hypotenuse. So I care about opposite and adjacent, so it's going to be a tan 7. Now I have the angle, I'm not looking for it, I have it. And it's opposite over adjacent. Okay, so if I solve this, tan of 7 is 0.123. So I put that over y. So I put this over 1 and I can multiply. I divide 75 divided by 0.123. I get 609.8. Now the other one's going to be very similar, except now it's going to be tangent of 0.5 equals 75 over z. So the tangent of 12.5, 222. So again, I put that over 1, I cross multiply. Final step would be to divide. So 75 divided by 0.222 is 337.8. So I have my y, I have z. X should equal y minus z. That'll be distance apart. So x should equal 609.8 minus 337.8. So 609.8 minus 337.8 is 272. So the ships are 272, and we were in meters apart. That was my final answer. So I know those can get a little tricky. Again, slow it down, pause it, ask questions through email, ask questions in person, and hopefully that makes sense. Have a great day.